Well, as you can see, the topic, it is acid, bases and salt. And why is it with a slash as a pH? We will be talking about all that later. But today's topic that I can tell you is going to be acid, bases and salt. Right, now before I get into all that, I just want to tell you that we all know the chemistry lab of the house is the kitchen. And who's the chemist over there? Definitely your mother. But you can also equip yourself slowly to, in the pretext of going and helping your mother, you can also know the different things that are around you. Right? Now, if you can see all these kind of things that I have put over here, they are all from what we get it absolutely easily available at home. Right? It might occur to you that why am I using all this? Now you know that chemistry is such a subject, I should say, that everything around us, we need to know the nature of those substances. Right? So what we will do today is we'll know whether they are acids or they are bases or if they are neutral in nature. So I have got everything from the kitchen itself. So what we use is, to know the nature of any substance, we need to use an indicator. So the indicator today that I'm using is beetroot juice. Okay. Now beetroot I have extracted the juice out of it, boiled water, cut the beetroot into pieces. As I was talking about indicator, all these beetroot, turmeric, these are all natural indicators. That means what we have something which is chemically used, which we'll be speaking about it later. Now let's see which other indicators or which other substances that I'll be using so that I get to know what is the nature of those substances. So right now what I'm using is either they would be acid or they would be bases. Okay. Now what is the indicator? What exactly an indicator does? The indicator changes color. Now as I'm doing this, remember when we are doing any kind of experiment, probably in the video you may not be able to see the color changes, but then I will tell you what are the color changes. Okay. So the first that I'm taking is vinegar. Okay. I'll take vinegar. Now what do we use in the chemistry lab instead of glasses? We use beakers. So as I don't have beakers, I'm using the glass. We use dropper. So I take the indicator. This is colorless. What I expect the color to be is very, very light pink. Okay. It is light pink. Got it? Next that I take is, now always remember we need to use separate spatula. We call them as spatula in the lab. Next I take lemon juice and I try to see what is the change in color. Here too I see that the pink color has slightly faded. What do we know that vinegar and lemon juice have in common? They are acids. Okay. Again, let's now take another substance, and that is the toilet cleaner, bathroom cleaner. What is expected over here is this should be base. This should be basic in nature. So the next one that I take is, this is colorless. Next what I put is the indicator. We usually use a dropper for that. Now what do you see? It remains colorless, right? And very, very light yellow in color. Okay? So what is the difference of color that we are seeing? Vinegar, it is slightly pinkish. Lemon juice, the color is changing almost into slightly reddish in color. In base or in bathroom cleaner, the indicator changes to colorless, or it becomes slightly yellowish in color. The last thing that I'm taking is again a cleaner, but this has ammonium hydroxide. Okay, now I have told you a chemical substance in it, but then of course it is also a cleaner, but it has a different substances compared to the bathroom cleaner. Okay, so what we use again, we take this. This is already yellowish in color, right? So let's see what is the color change. It almost becomes slightly, the pink color remains, but it will fade after some time and become yellowish in color. So as of now, this has certain detergents. It also has some other chemicals, flavors and things like that, right? So the color change is not seen that much. So usually what you see is, from the indicators that we use, the color changes, and the color change helps us to know whether any substance is acidic or if any substance is basic in nature. For now, I'm using all these 4 items, right? Now you can also try them, but please remember, be very, very careful whenever any experiment is done. Okay? Yes, I just would like to tell you, I do have bleaching powder. You know, bleaching powder is another cleaning agent, by the way. Bleaching powder, let's see what the changes in bleaching powder would be. Now, bleaching powder is obviously powder, it is amorphous in nature. Okay, amorphous means they are not crystalline. We take this, we try to make a suspension. Now, why do I use suspension? Probably you heard about this particular term. Suspension is something which does not dissolve. Not like if I would have taken sugar, then sugar would have dissolved and you would have got a clear solution. But when I take a amorphous powder, this does not dissolve. Now let's see what is the nature of bleaching powder. Again, I put indicator. It again goes colorless. What do I see? If it is colorless, when any indicator changes into colorless, that means this is basic in nature. The base is slightly more. Okay, so this is what we have done. You can also try it, but let me tell you, it is very, very necessary to take precautions when you're doing any kind of an experiment. What you can use in the kitchen, I'm sure that everybody has, is an apron, which I should have worn it. You wear this. Keep certain tissue papers with you and try to, why did I use a white base? So that you can see the color changes much more better. Okay, so we'll move on to the theory part of it after this. Alright, where we left off was that we were talking about acid and we were talking about base. Now, why am I actually separating them? Let's see that what are the different properties. The first thing is the color changes, right? The color changes in acid that we saw was what? The range was from red to pink, correct? In base, we saw it was colorless. And the
other thing that we saw was it was slightly yellowish. Now remember that the indicator that we used for all this was beetroot, which was again a natural indicator. Correct? Now when we are saying these color changes, remember these are not the substances that we used were not totally acidic or totally basic in nature. So that's why you see that the color changes are slightly different. Now let me come to the physical properties of acids and bases. When we talk about physical property, it is anything that we can touch, feel or see, right? Or even taste. So I'm sure all of you are aware of acid are usually sour to taste and they are corrosive. Now what would corrosive mean? Corrosive is something which gives a very rough nature or it burns. When any surface burns, that would be corrosive in nature. Okay? Bases are bitter to taste and they are soapy to touch, and that's why you see that most of them are used for cleaning agents. Alright? So we have bases and we have acids. I would very lightly touch on the indicators that we use in the lab. They are, and I'm sure all of you are aware of, are the litmus paper. They are blue and they are blue litmus paper and they are red litmus paper. Okay, and we have the color changes in that. Okay, now let me go a little deeper about indicators. What happens is, when I'm talking about the natural indicators, what are the two that I spoke about was beetroot and turmeric. Alright, and litmus, phenolphthalein and methyl orange. I'm not touching on them right now because there is something else that I want to speak about. If you remember, the topic that you saw was salt. There was also one term called salt. Now, how do we usually get salt? We usually get salt when we react any acid with a base, you get salt. And chemically, acids are substances which have H plus ions. That means when I say ions, they are charged particles. Bases have OH minus ions, okay, and they are again negatively charged particles. Salts are neutral, and that's why we can have salt. So what happens is, basically, whenever we add any acid and a base, then we get a neutral substance or salt, and of course we'll be getting water. Let me just show you an equation with an example. We take HCl. HCl, I'm sure all of you know, is hydrochloric acid. We take sodium hydroxide. This is the OH minus ion. And we get NaCl plus water, sodium chloride, and all of you are aware of it is common salt that we consume very easily. Okay, right? So we get a neutral substance. Now let me come, when I'm talking about beetroot, when I'm talking about litmus, they only show the changes, or we can understand the differences of the substances only when by the color changes. But we need to know which is much more acidic, because we know that we do consume certain substances which have acid in them. For example, we know that lemon is citric acid, right? We know vinegar also has acetic acid. So we do consume them. Is it that the acids are not, those acids are not very powerful? Yes, they are not very powerful, but we need to know the range, okay? to which is much more acidic, or which we can consume, which we can use, which we need to be careful of. Similarly, we also need to know the bases which are highly powerful. Okay, very, very powerful. They also, in fact, strong bases also can burn your wherever they fall. Okay, so the term that you were seeing was pH. Okay, now pH is power of H plus ions. Okay, so the range over here is, the scale I should say, is 7, 14, 0. So 0 to 14 is the scale, 7 is neutral, below 7 would be acid, above 7 would be bases. Here. So and the color changes accordingly. The color runs from red to yellow to purple. We have a pH meter, okay, which is actually done with electricity, or we have a pH paper. pH papers are yellowish in color, and these yellow colors are neutral. Okay, and as the color goes this way, when we move towards the base, they are from blue to purple, dark blue, then dark blue, and then the very strong alkalis would be purple. As we come down, then they become pinkish, and the very, very strong acids would be red in color. Alright? Well, when we are talking about acid, bases, salt and so on, why are we learning about all this? It all has its advantage and disadvantages, right? Ultimately, what we need to know is where we can apply them, correct? Right now, I'm going to show you a particular video. Go through it properly, and then we will follow what we need to do with that particular video. Okay? Just see this very carefully.
What is acid rain? Acid rain is any form of precipitation with high levels of nitric and sulfuric acids. It can occur in the form of snow, fog, and even dry materials that settle to earth. Most acid rain is caused by human activities. When people burn fossil fuels, sulfur dioxide and nitrogen oxides are released into the atmosphere. These gases react with water, oxygen, and other substances to form sulfuric and nitric acid. Winds may spread these acidic solutions over hundreds of miles. After it falls to Earth, acid rain enters water systems as runoff and sinks into the ground. This can make water toxic to crayfish, clams, fish, and other aquatic animals. The rest of the food chain, including non-aquatic species such as birds, is often affected as well. Acid rain also harms forests by damaging trees' leaves, robbing the soil of essential nutrients, and making it hard for trees to take up water. By designing cleaner power plants and using fewer fossil fuels, we can reduce the number of pollutants that create acid rain.
Right. So we have this. Now what do we do with this, right? What you can conclude from this particular video? Definitely that acid rain is actually affecting our environment, right? When we're talking about environment, the first thing is that it is not only affecting only the surroundings, but also or the earth, but definitely the human beings or all the living creatures, right? What I would like to do is, you can make a note about what are from the video, but I have 2 case studies to be done. Okay, how you represent it, I will definitely talk about it, but a very small worksheet that I will be giving you. Just a moment. Okay, now this is a very small worksheet. If you see that this is in the form of a flow chart. Okay, very small MCQ kind of questions, and this will be passed across to you. You have small questions again. Here is something that I would like all of you to concentrate on. This space, you have to create a poster. We just had World Environment Day yesterday, right? What we do is usually as human beings, we'll have slogans, we'll have certain videos made, and that's it, we forget it. I know that I'm asking you to make a poster again, but make the poster with a lot of thought, with the video that you have seen, and you can definitely go across and watch. I'm sure you know how a poster would be made, right? So you make a poster, all right, in your, for the residence, for wherever you are staying, and you definitely, what you talk about is pollution. All right. So this is the worksheet that I have just given you in connection with the video that you have seen and what I have mentioned little bit about acids and bases. Okay. What are carbonic acids? What are the different kind of acid solution? Definitely, you can research and you can do it. All right. It is all there in your chapter. Now, what I want you to concentrate on is this. All of you, just remember that when you're doing science, this word is very, very important. Exploration, research, all right? Do this so you know that acid rain or acids and bases is applicable in all these fields that I'm talking about. Okay? In the field of medical, all right, the medicines that we have, and I'm sure you've heard about that. Everybody and anybody under the sun, very common word, we suffer from acidity, right? We run, we go have medicine. But if you know that the first aid is present in your kitchen, it's baking soda. Baking soda is basic in nature. What did we learn? That when an acid combines with a base, we get a neutral reaction. So when we say neutral reaction, then what happens is you're suffering from acidity. The first aid is take little bit of base in it or baking soda, mix it with water, drink it. Right? So now you know the first aid at home that you can give everyone. Cosmetics. Now cosmetics, I'm sure all of you heard about these different kind of ads that go on, that before you're using anything, try to use it in your hand. Okay? See if you are allergic to it. Again, when there is any kind of allergy, it's because of the acid level not being constant in your body. It is higher. We need to neutralize it. Right? That's when a different kind of, actually very funny, baking soda or baking powder is actually the best base that you have in the kitchen. The other is toothpaste. Okay, so do these kind of research and you will see that you get more and more interested, that once you get to know where you can apply all your knowledge, that's when the interest starts. right? So I want you to go through all this. Food industry, definitely, right? Food industry, I'm sure you must have heard, and especially during this time that you're hearing, have health food, right? That means the junk food is something that is absolutely avoided. Because more of junk food, what do we have in our stomach? We have HCl. When we increase the acid level in the body, that's when that's the basic start of all the diseases. When the pH level is not balanced in the body, that's when the diseases start. Okay, I'm not talking about fractures or anything bigger, but very, very basic diseases start with the pH level not being controlled in the body. Okay, so do all these kind of research, and yes, you will find these YouTube channels. When you go through them, you will find the detail. There are different kind of experiments that you can explore. Okay, so exploration is something, the curiosity is something which should drive you to learn more and have more questions, and that's when you can get your knowledge and collect your knowledge. Right, coming back to this, the case study is the first case study where I'm giving you two case studies and anybody can take up any one of them. These are the questions that you have to do. The first case study is how pH affects the vegetation. Once you have acid rain, what is affected? The soil is affected. Once the soil is affected, definitely vegetation is affected of that particular area, right? How you can correct the pH level of the soil is what you need to see. How acid rain is affecting the geographical scenario of India is a very interesting topic. Once you go through it, definitely you'll see amazed that how the different states are actually coming down with their productions. Okay? Now, how do you need to represent them? You need to represent them, this particular case study, you need to represent them as a poster with captions and slogans. Okay? And also, wherever you are taking the either encyclopedia or any book that you have followed, anything that you are doing, please submit them as a research paper. Okay? The second case study is about how Taj Mahal is being affected by acid rain. Okay? Remember, Taj Mahal is again made of marble. Very simple. Marble is calcium carbonate. When acid keeps falling onto it, alright, they get corroded. So it's slightly turning yellowish in color. It's getting corroded. If you see, it is very, very scary to know that such a precious monument is getting spoiled because of our doings. If you have heard in the video that we are responsible for spoiling the environment around us. So these, of course the architectural effects due to the environmental hazards that are there. This particular topic, I want you to represent it as a comic strip. You're very, very aware about comics. All of you are interested on comics, I'm sure about it. So you represent it as comics, and then at the end, what you do is write down whatever you have taken the research from, either your YouTube links or the books. Okay, now this much for what I actually wanted to do today, but obviously a class is over only when we are make a summary of it or just conclude it. Okay, so what did we do? We just started with to see the different terms that we came across was indicator, and we have natural indicator and the synthetic indicators. What do indicators help us to do? It helps us to know the nature. What is the kind of nature that they help us to know? Whether anything is acidic or anything is basic. The next thing that we learned was when an acid combines with a base, we get a neutral substance. Indicators only help us to know the nature of the substance. pH helps us to know the strength of acid or base. Next was, we saw a video which is basically an application of acid and base. Alright, application of acid and base in the environment, pollution, and the hazards that we come across or we see around. Keeping that in mind, I give you a worksheet, of course, and the worksheet is in the form of a flow chart and 2 case studies which should allow you to increase your research aptitude or the exploration, the curiosity, so that you get to conclude that next World Environment Day, you will be much more aware when you are going ahead and speaking about something or talking about anything. Okay? Thank you. You know what, when I was going through all this, I came across a very interesting video. And let's just end it with this, with a little bit of music. Music and chemistry. Yes, even I was surprised, but then let's hear it. Okay? And let's end it with this particular music and more of fun. Alright? So just go through it. You can be probably using it even when you're doing any kind of those case studies that you see. Right? Okay, children, just go through it.
Bronsted and Lowry had a theory which they came up with independently. In chemistry, the difference between an acid and a base is a base except a proton which an acid donates. When litmus turned from red to blue, it indicates a change in solution from an acid to a base. In chemistry, the difference between an acid and a base is a base except a proton which an acid donates. The pH scale lets you see the level of acidity. Above pH 7 is where bases go. pH 7 is neutral with acids below. In chemistry, the difference between an acid and a base is a base except a proton which an acid donates. The pH scale lets you see the level of acidity. The difference between an acid and a base is a base except a proton which an acid donates. The difference between an acid and a base is a base except a proton which an acid donates.